Yeah, good evening, everyone. I'm hoping you guys are fine. Can you please comment if you hear me? And a fellow comment if we could at that side. Am I audible that side? Ka batho ba commentela hore ke utlwala ka puo tsala se ka re ke a hlanya jwale no. Ke la nkutlwa ka puo tsala nka da ba fethodisang ntle. Ana buang le nna sa. Kgona ho tswela pele fast la bo ka randa at least ka bo half past la be re kwala da idea. Yes, I can hear. La ke hololo sentse tswela pele ona da ka ho jaya fast. So I was hoping to do electrodynamics, but I was like, let me rather do the graph tse ra kgona ho di qetella fela. And then it means tomorrow we'll have 1 hour nyana to do electrodynamics. And we'll get to do electrodynamics tomorrow. So let's rather do photoelectric effect as a consolidation. So here we have a question 7. A learner is investigating the laser photoelectric effect for two different metals, silver and sodium, using light of different frequencies. The maximum kinetic energy of emitted photons is plotted against the frequency of the light for each of the metals, as shown in the diagrams below. They are wrong in the diagrams alongside Matata. So define the term threshold frequency. I define as 2 max yalpa. According to that definition we had given you there. Now let's try to investigate this graph. Graph is a graph of frequency and kinetic energy. So it means for this line over here, for this line of frequency, we are aware of Momo thing. We having a coordinate of y which is equals to 0. At this line of frequency, we have a coordinate of y which is equals to 0. So we should say where it is cutting, we are actually having what? We are actually having f0. We are actually having f what? F0. So bolela mo ke na le F0 le mo I have what? F0, because the kinetic energy here is what is equated to 0 there. So I'm saying for this type of graph, you should remember the y cut, the x cut is f0, f0. Now let's assume that this graph was actually like this, was actually extrapolated. Let's assume that this graph was extrapolated. Now I wanna know where we cut the y-axis. Where we cut the y-axis, what are we gonna call that? Where we cut the y-axis, remember this line ke line ya energy. So over here I would have an energy at 0. Why? Because for this y, I'm aware that the x value is 0. So I'm gonna have energy at 0, which is a W0. So I should know here that we're having W0 as negative. W0 as negative. Yeah, that's fine. Now let's try to answer the questions. Before, remember that this is called it will be called the independent variable, and this one would be called the dependent variable, and the controlled variable, in this case it will be a Planck's constant. Now I'm not sure how many people are watching this. When I say how many people, is it group 1 or group 2? If it's group 1, I had said that the equation is written like this of this graph. With group 1 we agreed that it is written like this, and with group 2 we agreed that the equation of this is written like this. I'm not creating fights between my groups. Remember, for other groups, what did I write there? Plus ek max. And then for the other group, we had said that it was ek max equal hf minus w0. So either way we're trying that thing, it's fine. The most appropriate one would have been the group 2 way. Even this one, according to the group 1, we made it to be the same as this one over the right hand side. Nonetheless, it's fine. So I'll try to answer my questions. 7.1.2, which metal, sodium or silver, has a larger work function? Explain your answer. Which one between the two, sodium and silver, has a larger work function? Remember that the formula of work function is saying W0 is equals to HF0. So we wanna know which one is gonna have a greater work function. It means in order for this to be greater, to be big, it means its threshold frequency needs to be big. Now I would compare between this one and this one. ke efe tlo bang le work function e kgolo. First way is that you can substitute the frequency there. You can substitute the frequency of each and calculate work function, compare the two, ubone ke efe kgolo. Or you can say between the threshold frequencies, I'm aware that this one is greater than this one. So you can as well say the threshold frequency of silver is what is greater than the threshold frequency of sodium, implying that work function of silver is gonna be larger than the one of sodium. Work function of sodium. Why is that the case? Is because of this formula over here. So you'll write down the formula and tell us the relationship or W naught is what is directly proportional to threshold frequency, provided that h is constant. So I'll underline the things which are important for this. So I'm saying you start where, and you'll start here saying this threshold of silver is greater than threshold of sodium. After that, it means work function of sodium is larger than work function of work function of silver is larger than work function of sodium. What is the reason? Reason is work function is directly proportional to threshold frequency, provided that h is constant, and we do know that h vele is a constant. So that would have been that. So what is key for this? What is key? The first one, threshold of silver and threshold of sodium difference there. Work function being larger, because the first thing you would have said, which one is larger? Silver. You write silver, they say your reason. I don't think these two are really unnecessary, this one. So if we was into it, it's fine. The other thing important is this one, because work function is directly proportional to threshold frequency. There's a proportionality there. As this one increases, this one increases as well. I'm hoping it's fine for that. 7.1.3, name the physical constant represented by the slopes of the graphs. Remember, slope is gradient. Now what is the gradient of this graph? Gradient is the same as the controlled variable, which is Planck's constant. So here they say name the physical constant. So I'll say the name there is Planck's constant. Planck's constant. Sometimes we say write down the value of the physical constant represented by the slopes of the graph. So you answer the question. In this case, question wanted the name, so you would write down the name. Hoping it's fine. Now let's go to the other one. If light of the same frequency is shown on each of the metals, in which metal will the ejected photoelectrons have a larger maximum kinetic energy? Can I erase there? Erase, 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 erase. Yeah. If light of the same frequency is shown on each of the metals, silver and sodium, in which metal will the ejected photoelectrons have a larger maximum kinetic energy? So it means we want to have this thing greater than the other one. So it would mean I would have to draw or to extend my graphs. So extending my graphs, I would do what? I would extend this and have a line moving like this, for example, and another line for this one moving like this. And we are told that they should have the same frequency. Let's say my frequency I choose to be the same as this one. It means I would move up to what? To touch my graphs. So this graph here, silver over here. I also move up again, up, to touch the other one of sodium like this. Now as I move along to the y-axis, that's where the kinetic energy is. For the same frequency, I go touch the graph and then I go to the maximum kinetic energy. So the maximum kinetic energy in this case, I see that when my graph it hits a silver, it goes where it goes to this kinetic energy. But when my graph touches sodium, it goes to that kinetic energy. Which one is larger between sodium and silver? The one for silver is this, the one for sodium is this. So the greater one should be sodium. Why sodium? I assume more get 10, more it 100. So 110, obviously 100 is greater than 10. So we have that type of question. O sebedise a graph. And this question puts something in maths. In maths, also we'll say sodium. So this thing puts something in maths called ogive. So that would really go ogive how like that. Immovable so the number of participators who won 10k. So the number king umuvichi or number, that number is the answer. Okay, I know what I'm saying. You don't know what I'm saying, then I don't know if you know what I'm saying. Is there any question based on this graph? If there's no question, I'll move to the other one. Okay, the other one is this one. So from this one, it's quite similar to the other one, but the difference is that along the x-axis, I'm no longer having frequency, but what I do have now is what 1 over 1 over 1 over wavelength. So let's check this investigation area. During an investigation, light is incident on zinc cathode of a photocell. The graph below shows the maximum kinetic energy of the released electrons versus the inverse of wavelength of the incident light. So we have maximum kinetic energy versus inverse that 2 free marks. Now we are name the quantity represented by x on the graph. It means now I require to do of a function. So how can I have the equation of this function? I would use equation. So if I was to check that along my y-axis, I am having max. So regroup one, Marata Shapa CJ, EK max yona y-axis. So ke tla qala ka yona ke tla re EK max is K max, go to the other side. So it is E minus W. No, I'm having Y is equals to something 5 sharp. I'm having what? I'm having 1 over lambda. It means I should change this energy to be what? 1 over Ebuanka energy and lambda. Yes, you do have that equation in E. Okay, go say I'll write it there. W naught. So multiplying 1 over lambda minus W naught. So EK max is equals to this. EK max is equals to HC multiplied by 1 over lambda minus W naught. And now that I made this to be what? To be the same as this one over here, I can now interpret my thing. Remember, this is y, this is x. Now I check a graph. Our function they gave us is a straight line, it's a linear function. So linear function has a format of y is equals to mc plus mx plus c, mx plus c. As we can all see, ek max is already y. Okay. Nonetheless, if we can check our hc is what is our gradient is m, and our y-intercept is negative work function. So let's check here, Barre. For that, independent is 1 over wavelength dependent variable. What is the constant variable? Like about h c. Okay. This one, 12.2, name the quantity represented by x on the graph. So x on the graph is the y-intercept, and we do know that the y-intercept is the value of c. So what is the value of c? The value of c is w naught. So it means x is w naught. Mara, write down the name of the quantity represented by x on the graph. I would say it's work function. Work function. Uh, and number three of that, calculate the threshold frequency of the meter. So how can I calculate the threshold frequency of the metal? How can I find threshold frequency of the metal? I wanna erase the, not all of it. This part is over wavelength. 1 over wavelength is what is this. So I do know what I can find what I can find would do what. And I wanna know a threshold frequency. So this would have been what HF naught plus EK yaga I do know at this. So I would have sub E. So let's quickly do it. I would say C that, so I'll say it's plus EK max, and then after that ke tlo etsang ke tlo re ke nane HC. Okay. Let's hope 1 over lambda. Reason why I'm separating those, because for this thing 1 over lambda, I'm gonna substitute this thing. I'm not gonna say 1 over this thing. No, where I see 1 over lambda, I'm gonna substitute this thing over there. So what I'm trying to say is that you would have had 6.63 multiplied by 10 to the power of negative 34 into our C is 3 times 10 to the 8 all over lambda. So 1 over lambda is what? 1 over lambda is this thing over here, which is what? 3.46 times 10 to the power of 6. So I'll multiply, or I'll rather put in a bracket 3.46 times 10 to the power of 6. So can you assist me out in punching that in the calculator. Can you assist me in punching that in your calculators there? This thing. And I got to move online thing. Got to move online on a hate food. Okay, it's fine. The answer is noted. I'll plug it in, and then I'll say it's equal after substituting the left hand side. Whatever that we did, we say it's equals to a 6.63 times 10 to the power of negative 34 f naught plus 0, and that thing we substituted on the left hand side there. After that, recurring, we would say, can I take it here? 6.88 times 10 to the negative 19 equal 6.63 times 10 to the negative 34 f naught, and then divide everything with 6.63 times 10 to the power of negative 34. Now what is the f naught we get? F naught or f naught is 1.04 times 10 to the 15 hertz, to the 15 hertz. So that would have been the threshold frequency ya meter. Sharp. I wanna erase everything here. I wanna take my answer first up there. Yeah. Okay, the other one, calculate the wavelength of light used from the following statement. Statement is the maximum kinetic energy of photoelectrons ejected from the metal when light of a certain wavelength is used is this. So the maximum kinetic energy of photoelectrons ejected, aka when light of a certain frequency is used. So now we say calculate the wavelength of the light used. So now that we know we know the threshold frequency. I can easily do what? I can easily identify work function. Besides that, I'm given EK max, so section ke tla sebedisa this formula, ring E equal W naught plus EK max. You know that we do it step by step. You would find what? You would find this. Afterwards, you do have this. You add them together, you get what? E. After E, you use that formula, ring E equal HC over lambda. Sharp. So we'll quickly do it to see if o na le potso tla nthiba ra o ska ba fair. So go E equal W naught plus EK max. So I'll say E equal HF naught plus EK max. So then E would be equal to 6.63 times 10 to the power of negative 34. And then F naught there how ke 1.04 times 10 to the 15 plus your EK max. Your EK max is 2.42 times 10 to the negative 7 is 2.42 times 10 to the negative 7. And now what is the energy you get there? If you say 6.63 times 10 to the negative 34 into 1.04 times 10 to the 15 plus 2.42 times 10 to the negative 7, what do you get? We're getting a 2.47 times 10 to the negative 17 joule. And then from there we would use this formula over here. So E equal HC over lambda. E is 2.47 times 10 to the negative 17, which is equal 6.63 times 10 to the power of negative 34. C get 3 times 10 to the power of 8 all over lambda. And then what do? You would cross multiply. Cross multiplying uthola F naught, uthola lambda S. Okay, let's do it step by step. 2.47 times 10 to the negative 17 lambda, which is equals to this part. Yeah, I'll just copy this thing. Copy, and I'll count paste, erase, erase, yeah, is equals to this. Afterwards I divide both sides with this, copy, paste, divide both sides with that. So in essence the lambda would become in essence lambda k, remember this it will cancel that, this is a layer, and we having that, so E equal 8.05 times 10 to the power of negative 9 meters, and this can also be written as 8.05 nanometers. Yes, Garanda or Faragant history. Now the last one of the graphs I had, I will read the statement there. Statements: an experiment is conducted to investigate the relationship between the wavelength of light incident on a metal and the maximum, so we trying to investigate wavelength of light and maximum kinetic energy of emitted electrons from the surface of a metal. This experiment is conducted for 3 different metals: lead, iron, copper, and gold. I would have to do this. Buffalo is a chief at our town. I'm just hoping it's clear. I'll zoom in and out. For now, I just hope you can see. The graph below represents the results obtained sharp. So we're given maximum kinetic energy, and we're given what? 1 over wavelength. So once again, I would do what? I would play around. Playing around. Can I play around? Let me shift this to the side and play around along here. Yeah. So playing around, play around. First formula, the one which is standard. And then I would play around. I'm aware of my Y is maximum kinetic energy. So get solver for maximum kinetic energy by transposing W naught to the side. So get EK max equal E minus W naught. Now remember, after that, I'm aware that this is Y sharp. Now I go to X. My X is a 1 over lambda. So I would change this to say it's HC over lambda minus W naught, and then I'm having what? EK max, and then let's check it what all rearrange this to make it what? 1 over lambda. So I would rearrange that. Ke tlo etsa ebe 1 over lambda. So ke tla ba le HC multiplying 1 over lambda minus W naught. And now that I'm aware that this is my X, this is my Y, the way I wanted them, I now check my graph. My graphs, I'm giving straight lines. Straight line is a linear function, and a linear function has this format of y equal mx plus c, mx plus c. So y k ek max, x is 1 over lambda. Sharp. Now okay, it's fine. As state photoelectric effect in words, I know that you'll take this 2 marks. If you got free 2 marks for you to take there. I won't go deep in it. Let's rather go and check the second question. Second question is write down the name bracket names. Write down the names or names of physical quantity or quantities represented by the graph of by the gradient of the graphs. So it's either it is 1 quantity or 2 quantities. So let's go. It would say gradient is m lekana in HC. So what is the gradient? Gradient is over name, by its name, it's over Planck's constant and speed of light. So ke tla ngola Planck's constant, Planck's constant, or and not or and speed of light, speed of light for that graph sharp. Which one of the 3 metals need incident light with the largest frequency for photoelectrons to be emitted? Give a reason for the answer. So which metal between the 3 needs light with the largest frequency for? So what is the question actually asking us? The question is asking us between the metals, which one is having the highest threshold frequency? Because which one of the 3 metals needs light, incident light with the largest frequency? So which one has the largest threshold frequency? I would come here. I don't know by inspection which one would be the one. But I do know, looking by the graph, oh man, I know, man. If I can check from the graph, I can read y-intercept. What is the y-intercept? Is C. What is C? C is work function, which is negative. if ke tlosa negative ke ba le work function obviously. So if I can check, or if I was to extrapolate my graph, let's extrapolate this graph. Ke tla line here like this, line of y. Now I wanna cut the graph for this one. I wanna cut the graph for this one as well. So let's say this is negative 10, this is gonna be negative 20, let's say this is negative 30. So which one is gonna have a greater threshold frequency? Greater threshold frequency is a greater thing. Why? Because these things are directly proportional. Greater threshold frequency, greater work function. So ke fe na work function e kgolo. Remember, work function ke tlosa fela negative ke work function. So if between 10, 20, 30, which one is greater? You would see that the greater one is a gold. The greater one is gonna be gold. So as we provide a resin the frequency is directly proportional to inverse of wave. Frequency is directly proportional to inverse of wave. Now number 4, the symbol X in the graph above represents the work function of ion. If the work function for ion is 9.945 times 10 to the negative 34 joules, calculate the maximum velocity of an emitted electron from the surface of ion if wavelength of incident light is 9 times 10 to the negative 11 meters. So I'll take it from there. In the statement, I'm told the work function of ion is this, and I'm also told wavelength of light is this, and I want to know the speed. So remember, I manipulate the W naught. After W naught, I find what? I find E. After E, I go to this formula. E equal W naught plus EK max. After that, I solve for EK max, and then I'll go to this formula, the last one. EK max equal half mv max squared. So let's quickly try to play around ka yona fele. E tla re W naught equal okay, I'm already given it. It's 9.945 times 10 to the negative 34 joules. Now I'll find energy of light. Energy of light is hc over lambda. H is a 6.63 times 10 to the negative 34. C is a 3 times 10 to the 8 all over lambda. A lambda there is a 9 times 10 to the negative 11. So what is the answer there? What is the answer for 6.63 times 10 to the negative 34 by 3 times 10 to the 8 over 9 times 10 to the negative 11? we're getting a 2.21 times 10 to the negative 15 joule. And then after that, I would go to this formula, E equal W naught plus EK max. So from there we have 2.21 times 10 to the negative 19, which is negative 15, which is equal 9.945 by 10 to the negative 34 plus EK max. So I'll solve my EK max. So me solving for this implies that I transpose this to the other side. So I'm left with EK max, and then transposing that to the other side, it will be 2.21 times 10 to the negative 15 minus 9.945 times 10 to the negative 34, and then EK max k. What is EK max there? I believe it was 2.21 times 10 to the negative 15. I believe it should be the big one. And the big one in this case is 2.21 times 10 to the negative 15 joules. I just hope I'm relevant. If I'm not relevant, you'll conscientize me there. And then after that, we go to the last thing, which is EK max formula. I'll say EK max is equal half m v max squared. So EK max is a 2.21 times 10 to the negative 15, which is equals to 1 over 5 into 9.11 times 10 to the negative 31, and v squared max. So I'll same answer. Okay, yes. So I'll divide both sides with this thing over here. I normally write it like this. I'll say I'm dividing with a 0.5 into 9.11 times 10 to the negative 31, such that I know that 1 over 2 is 0.5, and then I'll cancel this on this side, and then divide on this side. So can you tell me, okay, without telling me, and then after that I'll say what? I'll say, okay, v squared max is equal 2.21 times 10 to the negative 15 over 0.5 into 9.11 times 10 to the negative 31. And then I take the square root on both sides, square root. Reason for square root, I want to eliminate that squared. So in essence, v max equal a square root of that. What is the square root of 2.21 times 10 to the negative 15 over 0.5 into 9.11 times 10 to the negative 31? I can get the answer there. So the answer we get is 6.97 times 10 to the 7 meters per second. Yeah. So that would be that. Is it the last question there? Yeah, it's the last question. So yeah. Let me see. Let me confirm first. Yeah, last question. That one. Okay. Yeah. Last question. Okay. Let me see. Yeah. So I just wanna say thank you for your time. Thank you for your effort. We do know, okay, we don't know why we're doing this. Only God knows why we're doing this. And I'm just hoping that the all we do for this, I just hope it's worth it. And now before you exit the life, please take note that tomorrow at this time, till this time, I will have a life lesson where I will be doing electrodynamics. So please join the life and let's work there. Together we fighting education. And the only thing I can say for now is good night, sweet dreams. I guess I'll see you guys tomorrow. And once again, I appreciate the hard work and the effort. Alala ke holodo matadiana a orange farmo a pamisa. If you have a question, you can ask it. Thank you. before I close the live, is there any ask, is there any question, is there any clarity needed?